Hello friends, welcome to Success Hub Media. In this tutorial, we'll be learning how to collect like terms. If you are new to this channel, please like, subscribe and press the bell icon so you can be notified automatically whenever a new video is released. We'll start by taking a look at what like terms are. Thereafter, we'll learn when to collect like terms, and finally, we'll learn how to collect like terms. So what are like terms? In mathematics, like terms are terms that have the same variables raised to the same power, although they can have different coefficients. Take a look at example 1. We have 2x plus 3 equals to 5x plus 1. The variable in this case is x. The power of x on the right hand side is 1. There is an invisible 1 here. And the power of x in this case is also 1. So they are like terms, even though their coefficients are different. In this case, we have the coefficient of 2, and in this case, we have the coefficient of 5. Take note that the coefficient of x is any number that is frozen or married to x. So 2x and 5x are like terms. The like terms here are 2x and 5x. Note, numbers that stand alone are called constants. They can also be referred to as like terms. The constants in the above example are 3 and 1. They can also be referred to as like terms. So as you can see, the constants in this example are 3 and 1. They can also be referred to as like terms. Taking a look at another example, we have m minus 4 equals to 7 plus 8m. The like terms here are m and 8m. The variable here is m, and the variable on this right hand side is m. They are like terms because they both have the same power, which is an invisible 1 to which m has been raised. The constants in the above example are minus 4 and 7. They can also be referred to as like terms. When to collect like terms? You collect like terms when they are far away from themselves with the purpose of operating them together. Take a look at this example. We have 2m plus 3 equals to 11. We've already established that numbers that stand on their own are referred to as constants, and they can also be referred to as like terms. In other words, we have plus 3 and 11, which are like terms. They are currently far away from themselves. So in order for you to collect like terms, you move like terms towards each other. We already have 11 on our right hand side of this equation, of this equality sign. So it will make more sense for us to move this plus 3 to the right hand side. And when you are moving a number, a constant, or a variable from one part of the equality sign to the other side, in this case, we want to move plus 3 from the left-hand side of this equation. This equality sign divides this equation into two parts. This is the left-hand side, and this is the right-hand side. So if plus 3 is going to move from this left-hand side to the right-hand side, something will have to happen to its sign, which is plus in this case. So when it crosses over, it will become minus 3. A simple way to look at it is to look at this sign of equality as a river. You can look at the plus sign as a male. The rule here is that when a male, which is plus, in this case plus 3, when a male crosses this river of equality to the other side, it's going to become a female, which is minus. And if the reverse were to be the case, if this was to be minus 3, when minus 3 crosses this river of equality to the other side, it's going to turn to a male. So moving forward with this example, we are going to write down collect like terms. And as you can see, this 2m remains our 2m here. This equality sign, it remains this equality sign we have here. The 11 which we had on the right hand side before is this same 11. So as you can see, the plus 3 that crossed over has now become minus 3. So that is the rule you need to know when collecting like terms. That when you collect a like term such that they cross the sign of equality, the sign in front of them will have to change, either from plus to minus or from minus to plus, as the case may be. So 2m is equals to 11 minus 3 will give us 8. This is a step in mathematics which has already been taught in our previous tutorial. At this point in mathematics, or at this step, you will have to divide both sides by the coefficient of the variable which you are solving for, which is m in this case. So you are going to divide both sides by the coefficient of m, which is 2. We've already established that the coefficient of a variable is the number that is frozen with the variable. If you need more clarity on how to divide both sides by the coefficient of the variable we are looking for, you can check my previous tutorial on my channel. So moving forward, we are going to divide both sides by the coefficient of m. So as we can see, the 2m equals to 8 remains the 2m equals to 8. We have divided the left-hand side by the coefficient, which is 2, equals to, we have divided the right-hand side by the coefficient, which is also 2. So when 2 cancels 2, we are going to have 1m, which is also written as m. And when 2 cancels 8, we are going to have 4. So we can say m is equals to 4. Taking a look at another example, we have 3x minus 4 equals to 17. We've already established that the numbers are constants, so we'll have to take them to the same side. It's always preferable you move constants to the right-hand side. In other words, 17 is already at the right-hand side, so it is minus 4 that will have to cross over to marry up with 17. Since we've already established that when a minus sign crosses this river of equality, it will turn to a positive sign. It therefore means that minus 4 will become what? Plus 4. You got it right. So we are going to collect like terms. On collecting like terms, this 17 remains the 17 we have here. The minus 4 we had here earlier, which has crossed over, has now become plus 4. So we now have 3x equals to 17 plus 4. 17 plus 4 will leave us to 21. We now have 3x equals to 21. So at this step in mathematics, we'll divide both sides by the coefficient of the variable which we are solving for, which is x in this case. So dividing both sides by the coefficient of x, which is 3, we'll have 3 cancelling 3 to leave us with 1x, which is also written, we can also write as x. And we'll have 3 dividing 21 to leave us with 7. So x is equal to 7. Taking a look at another example, we now have 5x minus 4 equals to 18 plus 3x. We've already established that variables with the same power are like terms. In other words, 5x and 3x, they are like terms. Minus 4 and 18, they are like terms. It's always preferable we move our variable to the left-hand side and the constants to the right-hand side. So if we are to move our variables to the left-hand side, this is a sign of equality dividing this equation to the left-hand side and the right-hand side. Now, if we are to leave our variables on our left-hand side, it therefore means that 5x is already on the left-hand side, it will not move. Rather, the plus 3x, which was on the right-hand side, will have to cross over to marry up with 5x because we have interest in moving all variables to the left-hand side. The same thing applies. We are interested in leaving the constants on the right-hand side. 18 is already on the right-hand side. It therefore means that it is minus 4 that will have to cross over to marry up with 18. So we'll collect like terms. We'll have 5x, which we already have here written down. The plus 3x, which was on the right-hand side, has now crossed over. It has now become minus 3x. The equality sign remains. 18, which was on the right-hand side, remains on the right-hand side. And as we can see, the minus 4, which was earlier on the left-hand side, which has crossed over, has now become plus 4. So taking this equation forward, we can say 5x minus 3x. You can liken x to be anything. You can liken x to be apples. So when you say 5 apples minus 3 apples, it will leave you with 2 apples. So the same thing applies. 5x minus 3x will leave you with 2x. 18 plus 4 will leave us with what? 22. We now have 2x equals to 22. So we'll divide both sides by the coefficient of x, which is 2 in this case. So dividing the left-hand side by 2, we'll be left with 1x, which we'll write as x. And when 2 divides 22, we'll have 11. Example 4. We have 19 equals to 5 plus 2x. We've already established that it's always preferable we keep our variable which we are solving for on the left-hand side and keep all the constants on the right-hand side. So the first thing I would do in this case, I will just flip the equation around. Before I flip it around, I want you to understand that when I say A is equals to B, I can equally say B is equals to A. In other words, if this left-hand side is equal to the right-hand side, I can as well say the right-hand side is equal to the left-hand side. So we are going to flip the equation around. So by flipping it around, we now have 5 plus 2x equals to 19. Take note, we haven't collected like terms. I just flipped the equation around. That's because I want the variable we are solving for to be on the left-hand side. We haven't collected like terms. Take note. So sometimes it pays you to flip an equation around. So we have to collect like terms as our next step. On collecting like terms, we already have 2x on our left-hand side, which is exactly where we want it to be. Take note, it was plus 2x in the equation, but now it has been written as 2x. That's because when we want to write a number that has plus as the first number you are writing down, the plus becomes invisible. That does not mean that there is no plus sign here. There is an invisible plus sign. Okay? So we have written this 2x here. The equality sign remains. The 19, which was on the right-hand side before, now remains on the right-hand side. Now, 5 has crossed over. You might want to ask, how did it become minus 5? No sign of plus was written here. So how come it crossed over and it became minus 5? Whenever you see a number or an alphabet standing on its own without a plus or minus sign at its front, there is an invisible positive or plus sign. In other words, 5 has an invisible plus sign in front of it. That is the reason why when it crossed over to the right-hand side, it now became minus 5. Okay, so from this step, we'll go further by saying 2x equals to 19 minus 5, which is leaving us with 14. I believe you already know what to do at this step. It's to divide both sides by the coefficient of x, which is 2 in this case. So we'll divide both sides by the coefficient of x. That will leave us with 2 dividing 2, giving us x, and 2 dividing 14, leaving us with 7. Now, this is an assignment for you to try. Solve the following equations. We have 1, 2y minus 4 equals to 16. We have minus 3 plus 4m equals to 13. And we have 5n minus 2 equals to 13. You can leave your answers in the comment section below. And if there is any part of this tutorial which you don't really understand, you can point it out in the comment section and I'll take my time to explain it to you. If there is any other topic in mathematics you would like me to make a video on, let me know in the comment section. Don't forget to like, subscribe, and press the bell icon so you can be notified for future videos. Thank you for watching.